M4 Sherman, the tank that won by showing up. June 1944, Normandy. A Sherman's engine note rises behind a hedgerow as the commander stands half exposed in the turret, scanning for the flash that might mean a German 75 or 88. The tank is not the biggest on the battlefield, nor the most heavily armored, but it is there, again and again, in numbers that feel like an industrial storm. Inside, heat, cordite, sweat, and the thin confidence that comes from training and routine. The M4 Sherman didn't promise invincibility. It promised that the Allies would keep moving. The Sherman was not born from a single visionary sketch pinned to a wall. It was born from panic, arithmetic, and the hard lessons of 1940 to 41, when the United States watched modern armored war unfold in Poland and France, and realized, with uncomfortable clarity, that its own tank force was small, scattered, and technically behind the curve. In 1940, American tank development still carried the baggage of the interwar years: limited budgets, competing doctrines, and an army that had not yet fully decided what tanks were for. The German campaigns settled the argument in blood. Blitzkrieg wasn't magic. It was coordination. Tanks, radios, artillery, engineers, and air support stitched together into momentum. For the U.S., the key question became brutally practical. Could American industry build a tank force large enough, fast enough, and reliable enough to fight a global war across oceans? The answer would become the M4. The immediate American problem was time. The U.S. needed tanks now, not perfect tanks later. That urgency produced the M3 Lee Grant, an interim design that mounted a 75mm gun in a sponson on the hull because it could be engineered quickly and manufactured on an accelerated schedule. It wasn't elegant, but it was a stepping stone. It introduced the U.S. to mass tank production, standardized components, and the realities of training crews and mechanics at scale. But the M3's limitations were obvious even before its first battles. The high silhouette, awkward main gun arrangement, and the need for a proper turreted 75mm tank that could fight and maneuver like the best European designs. So even as M3 production started, ordnance engineers pushed ahead with a successor. The prototype program that mattered most was the T6, a design that used the M3's proven automotive elements as a foundation, but mounted the 75mm gun in a fully rotating turret. That decision wasn't just tactical, it was logistical. Reuse as much as possible, change only what you must, and turn the whole project into something factories could stamp out by the tens of thousands. By 1941, American rearmament was accelerating, and senior leaders who mattered, men tied to the Army's expanding armored force and to the Ordnance Department, were increasingly aligned on the same truth. Whatever tank replaced the M3 had to be good enough to win, but more importantly, it had to be buildable. This was the Sherman's first defining constraint. The M4's development reflected a uniquely American approach to armored warfare in a global coalition: standardize, simplify, and scale. Tanks were not just fighting vehicles. They were a system: spare parts, engines, transmissions, radios, ammunition, training, and shipping. A tank that looked impressive on a proving ground could become a catastrophe in Tunisia or New Guinea if it broke down, burned clutches, shed tracks, or demanded precision machining that a wartime supply chain couldn't deliver reliably. This is where the Sherman's reputation, sometimes misunderstood, begins. The Sherman was designed under the assumption that the U.S. would fight as part of a combined arms machine: artillery dominance, air superiority when available, abundant logistics, and constant operational movement. In that world, a tank's ability to start every morning, roll 100 miles, cross a bridge, be repaired by ordinary mechanics, and accept upgrades without halting production could matter as much as the thickness of its armor. That industrial logic shaped everything: hull construction methods, welded and cast, standardized turret rings, modular components, and a willingness to accept different engines if they kept the production lines moving. The Sherman was not one tank. It was a family, multiple variants built by multiple manufacturers, unified by a common battlefield role and a production philosophy that treated interruption as the enemy. The T6 proved itself quickly enough that the Army moved to standardize it. In October 1941, the design was formally accepted as the M4 medium tank. Timing mattered. This was weeks before Pearl Harbor, when the United States was still officially at peace, but already committed to becoming the arsenal for itself and its allies. The tank that would become the most recognizable American armored vehicle of the war was now on the clock, because history was. Factories that had never built tanks were pulled into the effort. The Detroit Arsenal Tank Plant, operated by Chrysler, became a symbol of America's industrial conversion. Other plants, automotive, locomotive, steel, joined the swarm. The Sherman's design had to survive not just the battlefield, but the assembly line. Every feature that required special casting capacity, exotic alloys, or delicate machining was a potential bottleneck. In a war of production, bottlenecks killed. And the demands weren't just American. Britain needed tanks immediately, and the Soviet Union would consume armor at a rate that stunned Western planners. Lend-Lease turned the Sherman into coalition hardware, shipped across U-boat-infested seas, unloaded in Africa, issued in Italy, delivered to the Red Army, and refitted by the British into specialized variants. The Sherman had to be adaptable, not merely to enemy tanks, but to Allied requirements, local modifications, and different doctrines. When Shermans first entered major combat, most famously in North Africa in 1942, they were, by the standards of that theater, formidable. A reliable medium tank with a 75mm gun that could fire effective high-explosive and anti-armor rounds, solid mobility, and good crew ergonomics compared to many contemporaries. Against early and mid-war German armor, and especially against the realities of desert warfare where mechanical reliability could decide entire operations, the Sherman's strengths were brutally practical. But war doesn't stay still. By 1943-44, the German response to Allied armor matured. Improved anti-tank guns, more lethal armor designs, and a battlefield increasingly shaped by long-range gunnery and ambush. The Sherman had to keep pace, without slowing production. So, modifications arrived in waves, each reflecting pressure from the front and the factory floor. Applique armor patches, revised hull details, and, most significantly, wet ammunition stowage, introduced to reduce catastrophic fires by surrounding stored ammunition with protective measures. The move from the 75mm gun toward the 76mm in U.S. service, while the British pursued their own solution in the Firefly, mounting the powerful 17-pounder to meet Panthers and Tigers with something closer to parity. Improved suspensions and, later, wider tracks and upgraded systems for better performance in mud, snow, and broken European terrain. Better optics, revised turret fittings, and incremental improvements that made the Sherman easier to fight in the real world, where visibility, communication, and fatigue could be as decisive as armor plate. The Sherman's evolution reveals its underlying truth. It was a tank designed to be changed. It was engineered not as a finished monument, but as a platform that could absorb lessons without collapsing the production schedule. That is a kind of battlefield intelligence in steel. By the time the Allies prepared to return to France in 1944, the Sherman had become more than a medium tank. It was an industrial commitment, a logistical promise, and a tactical compromise made at global scale. It was not built to win every duel. It was built so the Allies could wage war everywhere, continuously, until the Axis ran out of machines, fuel, and time. Sherman designed to be built by the tens of thousands, shipped across oceans, repaired in muddy fields, and fought by crews who might learn their trade in months, not years. The M4's engineering wasn't about maximal performance on a proving ground. It was about creating a dependable armored chassis of war, then ensuring that almost every part of it could be improved without breaking the supply chain. Sherman is a convenient label, but the wartime reality is messier and more revealing. The M4 was produced in a web of variants: M4, M4A1, M4A2, M4A3, M4A4, that often differed less in battlefield function than in how they were manufactured and what engine sat in the rear. The US accepted this complexity because the alternative was worse: a single engine, single plant bottleneck that could throttle output. That choice created the Sherman's most distinctive engineering trait: interchangeable sameness. From the outside, many Shermans look alike. Inside, production decisions hide in castings, weld seams, power plants, and subtle changes in hull geometry. The Sherman was engineered so that those differences could exist without turning the entire vehicle into an incompatible orphan. Two major manufacturing approaches defined early production: welded hulls, common on the M4, assembled from rolled armor plate sections. This method played well with American heavy industry and allowed rapid output with predictable metallurgy. Welded hulls also made certain repairs and modifications straightforward in the field or depot. Cast hulls, notably the M4A1, produced as large cast pieces with smooth curves. Casting enabled shapes that could deflect shots better than flat plates at the same thickness in some contexts, and it reduced the number of major weld seams. But it demanded significant foundry capacity and introduced its own production constraints. Both approaches existed at once because the point was not philosophical purity. It was manufacturing throughput. If a foundry could cast, cast. If a plant could weld, weld. Get tanks to ports. Keep the lines running. The Sherman's armor is where legend often overrides detail. On paper, early Shermans weren't thin-skinned compared to many 1942-43 contemporaries. Their real vulnerability emerged as German anti-tank firepower escalated faster than the Sherman's original armor scheme. Key concepts shaped the M4's protection. Sloped glacis. The front upper hull was angled to increase effective thickness and improve deflection odds. Angle mattered as much as raw millimeters. Cast turret forms. The turret's rounded shapes helped reduce shot traps in many cases, though not perfectly across all revisions. Trade-offs for mobility and production. A tank that is safe, but can't cross bridges, can't be shipped efficiently, and can't be built fast enough becomes strategically irrelevant. The Sherman's designers accepted that the vehicle would be hit, and survivability would come not only from armor, but from tactics, movement, and later internal safety improvements. By 1943 to 44, combat feedback pushed visible changes, applique armor in certain areas, and improved protective layouts. But the most meaningful survivability improvement wasn't an external plate bolted on in a hurry. It was ammunition. The Sherman's early reputation for catastrophic fires wasn't a simple morality play about bad design. Any tank carrying large amounts of ammunition and fuel hit in the wrong place can burn. But early Sherman ammunition arrangements made worst-case outcomes more likely, particularly when rounds were stored in sponson positions that could be penetrated by side hits. The U.S. answer was a set of changes collectively remembered as wet stowage, a reorganization and protection of ammunition storage intended to reduce fires and improve crew survival odds. It wasn't magic armor. It was internal engineering aimed at the most common, lethal sequence: penetration, ammo ignition, crew loss. This was one of the Sherman's most important design evolutions because it shows what adaptable platform really means. Not just bigger guns, but better odds for the men inside. The Sherman's original main gun, 75mm, was a purposeful choice. Its virtue was versatility. It could fire high explosive HE rounds effective against infantry positions, buildings, anti-tank gun nests, and field fortifications. Armor-piercing, your AP, rounds that could defeat many early and mid-war German tanks under typical combat ranges and angles. Smoke and specialized rounds supporting combined arms tactics. That flexibility suited Allied operational needs, especially in theaters where tanks spent as much time blasting strongpoints as dueling armor. But in Northwest Europe, the battlefield argument changed. Tanks increasingly faced Panthers, up-gunned Panzer IVs, and well-sighted anti-tank guns. The 75mm remained useful, especially for HE, but crews and commanders wanted more anti-armor reach and penetration. Two main solutions emerged: US 76mm gun, improved anti-armor capability, and higher velocity compared to the 75mm, at the cost of somewhat less effective HE in some contexts, and a continuing need for good shot placement against the most heavily armored German vehicles. And British Firefly conversion. The British mounted the 17-pounder in the Sherman, creating a variant capable of killing Panthers and Tigers at ranges and angles that ordinary 75mm Shermans could not reliably match. This wasn't simply a better gun, it was a doctrinal adjustment, embedding a tank killer capability inside units that were otherwise built around the Sherman's general purpose role. The key point? The Sherman became a battlefield ecosystem. Some Shermans carried the best HE. Some carried the best anti-armor gun. Units learned to fight as a mix. One of the Sherman's most striking engineering features is how many engines it could accept, because the war demanded it. Different variants used different power plants depending on what industry could provide in volume. That meant different maintenance quirks, different parts pipelines, and different performance profiles. But it also meant production could surge without being hostage to a single engine supplier. What mattered most for a medium tank intended to fight across continents was dependable starting and running in harsh conditions, serviceability by average mechanics, spare parts availability, acceptable fuel consumption for long operational pushes. Shermans were not fragile thoroughbreds. They were designed to be rugged, trainable, and maintainable. Vehicles that could be kept alive by crews and support units working under fire and exhaustion. Early Shermans used suspension systems that were effective and straightforward, but the war kept raising the same question. Can it keep moving when terrain stops being test track and becomes mud, snow, rubble, and cratered farmland? The Sherman's running gear evolved with improvements that addressed flotation and handling, including later refinements that helped it cope with Europe's soft ground and winter conditions. Wider track solutions and suspension upgrades weren't glamorous, but they were decisive. A tank that bogs down becomes artillery bait. A tank that keeps moving stays dangerous. Ask veterans what makes a tank good, and you often hear less about raw armor thickness than about what it's like to fight the machine. The Sherman was widely considered a workable crew environment by wartime standards. Generally decent visibility relative to many contemporaries, effective radios that supported coordination, layouts that crews could learn and maintain, turret arrangements that, while not luxurious, supported a steady fighting rhythm. This matters because armored warfare is a crew sport. A tank that is 10% better on paper, but exhausts its crew, breaks down, or blinds its commander can lose to a lesser machine that keeps functioning. The Sherman was engineered as a mass-produced, upgradable medium tank platform, optimized for strategic mobility, reliability, and battlefield adaptability, rather than a single, over-specialized dueling champion. That design choice would collide, hard, with the realities of late-war Europe, where the battlefield often demanded duels anyway. And that collision, between design intent and combat reality, is where the Sherman's story becomes most human. The Sherman's legend lives in extremes. To some, it was the dependable workhorse that carried Allied armor across 3 continents. To others, it was a death trap sent against superior German guns. Both views contain truth, and both can become dishonest if you strip away context: when, where, which Sherman, and how it was fought. Because the Sherman wasn't tested in a laboratory. It was tested in dust that ate bearings, in bocage that hid anti-tank guns, in Italian mountains that punished transmissions, and in winter mud that turned tracks into anchors. It was tested by crews who slept beside it, cursed it, repaired it, and, often, trusted it more than they trusted whatever came next. Across Allied armies, one of the most consistent praises for the Sherman was blunt. It worked. In North Africa, especially in late 1942 and early 1943, that mattered. A tank that can't move is not a weapon. It's a static target. The Sherman's automotive reliability, compared to many contemporary designs, made it a vehicle that could be kept operational through routine maintenance and aggressive parts replacement. That doesn't mean it didn't break. It broke constantly, because all tanks do. But the Sherman tended to break in ways mechanics could fix, with parts that existed in the pipeline and procedures that were quickly standardized. The U.S. Army, in particular, treated maintenance as doctrine, not housekeeping. Units trained to recover disabled tanks, swap powertrain components, and return vehicles to the line quickly. In practice, that meant the Sherman's real combat power wasn't just the tank itself. It was the recovery half-track, the wrecker, the ordnance truck, the spare road wheels, and the mechanics who could tear into a bogey assembly under rain and shell fire. The U.S. also learned fast that reliability was a relationship between machine and environment. Desert sand punished engines and moving parts. Italian terrain strained brakes and drivetrains. Normandy's hedgerows forced tanks into low gear, high-stress movement. Winter fighting pushed lubricants and batteries into failure. The Sherman's advantage was that it had enough robustness and enough industrial support that these problems didn't stop the Army. A German Panther might offer formidable armor and gun performance in the right conditions, but it could also be immobilized by mechanical failure, fuel shortages, or damage that overmatched field repair capacity. The Sherman's winning statistic wasn't the thickness of its glacis. It was operational availability. How many tanks you can actually bring to the fight on Tuesday, and how many you can bring back on Wednesday. The darkest part of the Sherman story is fire. Crews feared it. Veterans remembered it. Enemy gunners aimed for it. And post-war memory, sharpened by grief, sometimes turned it into the Sherman's defining characteristic. The truth is more complicated, but not comforting. Early Shermans carried ammunition in locations that could be vulnerable to penetrations, especially from the side. When armor was pierced and ammunition ignited, the results were catastrophic. That reality produced accounts, particularly from the 1944 fighting in France and beyond, that cemented the Sherman's reputation as prone to burning. But it's also true that the U.S. made specific engineering changes to address this, and those changes mattered in crew survival. Wet ammunition stowage and revised internal arrangements reduced the probability of deadly ammo cook-offs in many hit scenarios. It didn't make the Sherman immune. Nothing did. But it shifted odds, sometimes the only kind of mercy war allows. Survivability also wasn't just about whether a tank burned. It was about whether the crew could get out. Here, Sherman ergonomics, hatches, interior layout, and the crew's familiarity with emergency drills could make the difference between a destroyed vehicle and dead men. Crews developed rituals, hatch discipline, escape rehearsals, not stowing personal gear in ways that blocked movement, keeping extinguishers accessible, and learning the reflexive motions that turned panic into seconds saved. And there was another factor that rarely appears in simplistic debates. The Sherman's main gun, especially the 75mm, was superb for high explosive fire, which meant Shermans could often suppress or destroy the anti-tank weapons most likely to kill them, if they saw them first, and if doctrine and terrain allowed them to fight the tank as part of an infantry artillery team instead of as a lone duelist. By the time Allied forces entered Northwest Europe in 1944, the Sherman increasingly faced German weapons that punished mistakes. the 75mm and 88mm anti-tank guns, Panthers in overwatch positions, and ambush tactics that turned hedgerows into firing ranges. This is where the Sherman crew's lived experience becomes central. A Sherman crew didn't sit around arguing armor thickness. They worried about who sees who first, whether your gun can penetrate before theirs does, whether you can back out of danger or get trapped, whether someone clears the flanks and the close threats, whether you can blind or suppress the guns that hunt you. Sherman units adapted because they had to. Crews learned to fire smoke to obscure deadly lanes. They learned to use terrain aggressively, cresting only enough to shoot, then reversing. They learned to fight with overwatch pairs, to avoid pushing single tanks into likely kill zones. They learned, often painfully, that German anti-tank teams, mines, Panzerfausts, and close ambushes, could kill a Sherman faster than a Tiger could, and armies adapted at the organizational level. The British integrated Fireflies to give Sherman troops a true long-range anti-armor punch. U.S. units increasingly emphasized 76mm armed tanks, where available, while also relying heavily on tank destroyers, artillery, and air support to reduce the burden on the medium tank. The Sherman's answer to Panthers and Tigers was rarely just Sherman versus Tiger. It was Sherman plus artillery, plus infantry, plus engineers, plus radios, plus logistics. A very different kind of battlefield mathematics. Inside a Sherman, war was intimate. The engine heat crept forward. The turret amplified every impact. The smell of fuel and oil never quite left. In summer campaigns, the interior could become a furnace. In winter, metal surfaces bit like ice. Crews slept on the tank, under the tank, or in shallow holes near it, because a tank is both weapon and shelter, and because moving with it often meant living with it. And they worked constantly. Tracks were maintained like lifelines. Bogies were inspected. Guns were cleaned. Radios were checked. Ammunition was restowed. A crew that neglected maintenance wasn't lazy. It was dead. The Sherman's reputation for reliability didn't happen by magic. It happened because armies built a culture where maintenance was part of combat power, and the machine itself was designed to reward that culture instead of punishing it. When the Sherman performed well, it performed in a way that crews valued: predictable handling, steady gunnery, and the sense that you were driving a tool built for war, not a temperamental prototype. When it performed poorly, it did so in the worst possible way, by being outranged, outpunched, and sometimes set alight before the crew could understand what hit them. The Sherman was therefore a paradox in steel, a tank that could be mechanically dependable and tactically vulnerable at the same time, depending on enemy weapons, terrain, and doctrine. That paradox shaped how men fought in it. It also shaped how they remembered it. The Sherman fought the way the Allies fought, as a moving part in a larger machine: infantry, engineers, artillery, air power, and logistics, grinding forward until the enemy's tactical brilliance couldn't compensate for strategic exhaustion. That doesn't make the Sherman's battlefield story simple. It makes it global. The Sherman's first major battlefield reputation was built in the desert, where a tank's worth is measured in dust, distance, and whether it starts in the morning. British forces first fielded Shermans in significant numbers by late 1942, and they were immediately valued for a reason that sounds mundane, but wins campaigns. They were mechanically dependable and tactically flexible. When U.S. forces met the Germans in Tunisia in early 1943, the learning curve was steep. At Kasserine Pass, February 1943, American units suffered from inexperience, poor coordination, and the brutal efficiency of German anti-tank guns and combined arms tactics. Shermans were lost, sometimes rapidly, but the lesson wasn't the tank is useless. The lesson was that a medium tank sent forward without infantry cooperation, reconnaissance, artillery preparation, and disciplined movement becomes a target no matter what name is painted on the hull. As U.S. and British forces improved their coordination through spring 1943, Shermans became instruments of momentum, pushing through gaps, exploiting after artillery smothered defenses, and providing direct fire against strong points. In North Africa, the Sherman wasn't a tragic underdog. It was a modern medium tank in its intended environment, used with growing competence inside an expanding combined arms doctrine. In Sicily, July 1943, and then in the long Italian campaign, the Sherman's role often shifted away from tank versus tank drama and toward the grim work of breaking positions. Italian terrain punished armor. Narrow roads, steep grades, stone villages turned into fortresses, and artillery observers who could see everything. The Sherman's value here was its steady mobility and its 75 mm high explosive capability, flattening machine gun nests, punching holes in walls for infantry, and suppressing anti-tank guns long enough for engineers to clear obstacles. At places like Salerno, September 1943, and later around Anzio, January 1944, Shermans became the armored spine of fragile beachheads, countering German armored probes, providing mobile firepower, and serving as psychological anchors for infantry under shell fire. Crews learned a specific Italian truth. The enemy tank was dangerous, but the real killer was often the gun you didn't see, an anti-tank piece tucked behind stonework, or an artillery concentration that could cripple tracks and suspensions without ever dueling you in the Hollywood sense. On 6th of June 1944, Shermans came ashore to the coast of Normandy in multiple forms, including the specialized amphibious duplex drive tanks used to support the assault waves. The moment is famous because it shows the Sherman's broader story. The tank wasn't just a gun and armor. It was a platform that could be adapted. Floating skirts, engineering variants, mine-clearing rigs, bridge layers, an ecosystem of steel built around a common chassis. Then, Normandy's bocage began to teach its own lessons. Hedgerows turned fields into compartments and roads into ambush corridors. German defenders, often outnumbered, learned to let the Sherman come close, then strike from concealment with anti-tank guns, Panzerfaust teams, or a well-positioned Panther firing down a lane. Sherman units adapted with a kind of battlefield innovation that rarely gets the attention of armor thickness arguments. They welded improvised hedgerow cutters, the rhino devices, onto tank noses to punch through embankments without exposing thin bellies to German fire. They fought in pairs or small groups with Overwatch. They coordinated more tightly with infantry, because in Normandy, the infantryman's eyes and the tank's gun were a single weapon system, or they were nothing. Operations like Epsom, June 1944, and Goodwood, July 1944, showed both faces of the Sherman War. Massed armor could drive deep when conditions allowed, but anti-tank defenses could turn open ground into slaughter if movement became predictable and support faltered. Shermans could win ground. They could also burn in rows when caught in pre-sighted fire. Then came the rupture, Operation Cobra, late July 1944. When the breakout finally began, the Sherman's strengths returned to the foreground: mobility, reliability, and numbers. Once German lines were cracked and the battle became one of pursuit, exploitation, and collapsing command structures, Shermans did what they were designed to do: keep moving, keep pressure on, keep turning tactical success into operational collapse. In Normandy, the British solution to German heavy armor took an iconic form: the Sherman Firefly, mounting the 17-pounder gun. This mattered in the kind of engagements that shaped morale, when a unit knew it had at least some vehicles that could kill a Panther or Tiger at realistic combat ranges. One of the most famous episodes came on 8th of August 1944 during the fighting south of Caen. A Tiger commanded by the renowned German tank ace Michael Wittmann was knocked out during an Allied ambush near Saint-Aignan-de-Cramonil. The kill is often credited to a Firefly gunner in the 1st Northamptonshire Yeomanry, though the exact attribution has been debated over time. What matters for our story isn't the legend, it's what the legend represents. Allied armored units needed a way to answer German heavy armor with something other than luck, artillery, or airstrikes. The Firefly gave them that chance. As the war moved into France and Belgium, Sherman formations were increasingly veterans, crews who had learned to respect German anti-tank weapons and to exploit their own advantages. In battles like Aricourt, September 1944 in Lorraine, American armored units fought complex engagements in fog and rolling terrain where tactics and gunnery mattered as much as raw armor. Shermans and tank destroyers using concealment, maneuver, and coordinated fire to blunt German counterattacks. Then winter hit. In the Ardennes, December 1944, the Sherman fought in the kind of conditions that punish machines and men alike: freezing temperatures, slick roads, limited visibility, and desperate infantry actions around villages and crossroads. Here, the Sherman often became what Allied doctrine always assumed it could be when needed: a mobile bunker, a direct-fire artillery piece, and, sometimes, the only thing standing between a German spearhead and an open road. The bulge wasn't won by any single tank model, but Shermans were everywhere in the fight, holding, counterattacking, and rolling forward again when the German offensive spent itself. By spring 1945, the operational story tightened into inevitability. Shermans crossed rivers on engineered bridges, pushed through collapsing defenses, and fought the short, sharp battles that happen when an army is still dangerous but no longer cohesive. Whether at bridgeheads, towns, or road junctions, the Sherman's role remained consistent: carry the infantry's firepower forward and keep the battlefield moving in the Allies' direction. In the Pacific, the Sherman fought a different enemy in a different world: jungle, coral, volcanic ash, and fortified caves. Here, tank versus tank combat mattered far less than surviving mines, close-quarters attacks, and anti-tank guns hidden in natural rock. Shermans were used by U.S. Army and Marine units as assault tools, often fitted with modifications, including flamethrower variants, to burn defenders out of positions that infantry alone would pay for in blood. This is the Sherman's operational identity in its purest form: not a dueling champion, but a battlefield enabler, adaptable, available, and constantly present wherever Allied armies fought. The M4 Sherman was never a promise of invulnerability. It was a promise of presence, that Allied armored units would arrive on time, in strength, with vehicles that could be maintained, supplied, and replaced faster than the enemy could destroy them. In 1942-43, that reliability and versatility made it a dominant medium tank in many fights. In 1944, against Germany's best guns and heavier designs, the Sherman's limitations were real and sometimes lethal, especially when terrain and doctrine forced it into frontal duels. But the Sherman adapted: improved ammunition stowage, better guns in key variants, specialized engineering forms, and, most importantly, an entire logistical and combined arms system that let it keep fighting when better tanks often could not. Its historical impact is measured less in single combats than in what it enabled: operational tempo, coalition standardization, and the relentless momentum that ended the war. This is Steel Doctrine: legendary war machines, real history, no myths. Write in the comments which tank you would like to hear about in the next episode. Subscribe, and uncover history forged in steel.